All right, so today we're going to talk about dilations. Okay, a dilation is a transformation that makes our figure larger or smaller. Oh, yes. Okay, so let's talk about the pupil concept. Same shape, right? It stays a circle, but either your pupils, well, when they dilate, right, they get really big. Or they get really small. Hold on. Well, either one depends on if there's light, right?
Darkness, and they get small and light because when they're bigger,
Yes.
it gets more light.
It tries to get more light put in. So that's what when you go to the doctor, they like test to see if your pupils react, right? Anyway, we are going to take a shape and we are going to stretch it to make it bigger or shrink it to make it smaller. But what's going to happen? It's still going to be the same shape. So it's going to be a similar figure. Okay. It's going to be a similar figure. So we're going to have an enlargement or a reduction. Okay. First of all, let's talk about the scale factor. The scale factor, we're going to call it K. Okay. It's the amount we're going to stretch or shrink our shape. So if our scale factor is 2, what do you think is going to be true about our shape? Its size is going to be double. Okay, so it's going to be twice the size. Okay, if our scale factor is 1/2, our shape is going to be half the size. Okay, so it's going to tell us how big or how small our shape is going to dilate to. All right, if K is bigger than 1, we have an enlargement because that means our shape is getting bigger. But if K is smaller than 1, that means we have a reduction because our shape is getting smaller. Okay, so I'm going to have you go ahead and turn the page. We are going to come back to page 114. Oh, you don't have to turn the page, just kidding. We're going to slide over to page 115. Okay, and we're going to look at what happens to our coordinates when we have a dilation. So let's pretend that our coordinate is x comma y. That's the pre-image. Okay, and on the coordinate plane, our dilation is going to be centered at the origin. So like that A point that we were moving all around, that's going to be the origin. We're just going to keep it there. Okay. If we have a scale factor of K, then what we're going to do is we're basically just going to multiply our coordinates by K. All right. Yep. So let's go ahead and do an example with real numbers. So let's pretend that point A is -1, 4. And we have a scale factor K equals 20. All right, so A prime is our image. What are we gonna do to -1? Multiply it by 20. What are we gonna do to 4? We're gonna multiply it by 20. That it's as simple as
So if the dilation is 20, would we do with A, B, C, and then D? If there's any other coordinates?
we would.
What's for lunch?
Food.
There better be.
Okay. Okay, now I want to slide back over to page 114, and I want to talk about this picture right here. Okay. So this point right here in that Desmos activity, that's what we were like kind of moving all around, right? Here is our pre-image. Right? And then in purple, I'm gonna highlight our image. Okay, so let's just pretend for a moment that I tell you that this distance right here is 5, and this distance right here is 20. From this picture, we can figure out what our scale factor is. Who thinks they know what it is? How'd you get that? Okay, so 20 divided by 5 equals our scale factor of 4. Right? Okay. But what we are going to do is we are going to use the origin as this C when we're in the coordinate plane. Okay, and what I'm going to ask you to do is I'm going to ask you to figure out what our image is based on a certain dilation. So if you could please turn in your packets to page 10, it should look like this. So let's go ahead and go to this first problem, and I want you to take a moment to plot the coordinates ABC. If K equals 2, what's going to be true about our image when we plot it? Okay, timesing it by 2, what'd you say? Okay, so we have an enlargement, right? K is greater than 1, our shape is going to be bigger. Specifically, it's going to be twice the size. Okay, so A is going to now be at A prime, I guess, -3, not -3, -4, 6. Because we have to double each of the coordinates. B prime would then go to what? 6, 2. Okay, and C prime would go to 0, -6. So my purple shape is our new image, okay? If we, you don't need to draw this with me, but our origin is what we're basing these off of. So if we think about the distance from the origin to B, it gets doubled to B prime. The distance from the origin to C, it gets doubled to C prime. Same thing with A. Okay, so you can kind of imagine that like illusion, right, of growing that shape. Okay. All right, our second example is really interesting because our pre-image has a coordinate at the origin. That coordinate won't, but the other ones will, right? Okay, so go ahead and plot ABC for me, please. Okay, so if K is 3, what happens to point A? Nothing, it stays. Okay, but B will now become 9, 0. And C will now be 9, 6. Next semester, we'll have this shape a lot, talking about how this triangle is similar to this triangle. And we'll use those similar triangle relationships to find some information. There's a chance. Next chapter, so next week we're going to start our congruent triangles chapter. Some good proofs of that one.
Oh gosh. Oh, yay.
Okay. Okay, let's go to number 3. Is this an enlargement or a reduction? It is a reduction because K is less than 1. So let's go ahead and take the time to plot our pre-image. What?
Oh, never mind. I see.
Okay.
I spaced out. I understand.
Do ya?
Yep. Stop it.
There's really not a lot of fluff to this section. We take all of our coordinates and we multiply them by a number. Okay. It helps if you write them down. So A prime becomes
5.
-5, 5. And B prime becomes -3, 4.
Oh, I did do it right.
And C prime becomes,
-4, 2.
see, you don't even need me today. There, that looks a lot like a picture we saw in our warm up, right? If I draw those lines. I don't know if the triangle is the same, but it was a triangle, right? Okay, our last problem we'll do together and then you can get started on your homework. What's going on in this one? I don't know what you just said. Okay. What kind of dilation do we have?
Reduction.
Thank you. All right, so where's A gonna go? A prime becomes -1, 1. B prime,
-1, -2.
and C prime. He's so cute. No. Okay. So it is your job to do pages 115 and a 116 out of your student journal. That is your homework.